Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 2 to the power of n plus 4 to the power of n plus 8 to the power of n equals to 39, and we will solve this problem for the values of n, or the real values of n. So here you remember one thing is that our n belongs to R. So here we solve this problem for real values only. So the very first thing we are going to do is, here first we rewrite this equation as, here you have 2 to the power of n plus we write this 4 as 2 squared and its whole power n, plus we write this 8 as 2 cubed and its whole power n equals to 39. And in the next step we will use here the nice exponential law. So you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of m times of n. So that we use here this nice law on these two terms, or you know that again this expression equals to a to the power of n and its whole power n. It means that if you can interchange these two exponents, then it cannot be affected our final answer. So that here we need to just change these two exponents and these two exponents as well. So that first we write this equation as 2 to the power of n plus, now we interchange these two exponents and we write 2 to the power of n and its whole square, plus again we interchange these two exponents and we write 2 to the power of n cubed equals to 39. And now we convert this nice exponential equation into the cubic form, so that here we need to take y equals to 2 to the power of n. So when you take y equals 2 to the power of n, then the above expression will becomes y plus, here you get y squared, plus when you put here then you get y cubed, and we move this 39 in the left hand side and minus 39, and this whole equation equals to 0. So that in the next step we will rearrange the terms and we will write this expression as y cubed plus y squared plus y, and now we write this 39 as minus 27 minus 12 equals to 0. So after this step we will combine the cubic terms, and we have the cubic terms are y cubed, and we write this 27 as minus 3 cubed, and the remaining terms are y squared plus y minus 12 equals to 0. So in the next step we will again simplify this equation, and we write it as y cubed minus 3 cubed plus we have y squared plus y, and we write this 12 as minus 9 and minus 3, and this whole equation equals to 0. So that here we need to take little bit simplifications, and we get y cubed minus 3 cubed, plus here we combine this y squared by 9 and you get y squared minus 3 squared, and we have plus y minus 3 equals to 0. So now we can make the factors of this equation. And now in the next step here we need two formulas, one is cubic and the other is square. So now first I can write here the cubic formula, and you know that if we have a cubed minus b cubed it is equals to a minus b times of a squared plus ab plus b squared, and our square identity is a squared minus b squared equals to a minus b times of a plus b. So we have these two cubic and square identities, and now we can use these two identities in order, and we simplify the above expression so that our above expression will becomes in this form. So first I can use here the cubic formula on this term, and you will get here y minus 3 times of y squared and plus 3 times of y plus 3 squared, plus here we use the square identity and you obtain y minus 3 times of y plus 3, and we have plus y minus 3 equals to 0. So now you focus on each of the term, and you see here we have y minus 3 be the common term on each of the expression, so that we take y minus 3 as a common, and you get here y squared plus 3y plus 9. Here you obtain y plus 3, here you have plus 1 equals to 0. So now we can rearrange the terms, and we get y minus 3 times of y squared plus 3y plus y is 4y, and 9 plus 1 is 10, and 10 plus 1 is 13 equals to 0. So that here we have two cases. The first case is we write y minus 3 equals to 0, and the other case is we write y squared plus 4y plus 13 equals to 0. So in this case we have y equals to 3, and now we check is this quadratic vein has real roots or not by using the nice discriminant formula. So that according to discriminant, here first I can write the coefficients of the term, and we have a equals to 1, b equals to 4, and c equals to 13, and our discriminant formula will be delta equals to b squared minus 4 times of ac. And now we put the values of a, b and c here, and you obtained 4 squared minus 4 times of a into 13, and you have 4 square is 16 minus 13, 13 4s are 52. So you get here minus 36, and you see that it is less than 0. So this discriminant formula tells us that if our delta is less than 0, it means that it has no real root. So if it has no real roots, then we will reject it this case, and we can just proceed here this case only. So in this case we put the value of y here, and you see that we have y equals 2 to the power of n. So now we back substitute the value of y, so you get 2 to the power of n equals to 3. And now in order to find the value of n, we need to take the log on both of the sides. So you have ln of 2 to the power of n equals to ln of 3. So now we apply the property of log, and we move n in the front of this log, and you get n times of log 2 equals to log 3, and we move this log 2 in the right hand side, and you get n equals to log 3 over log 2. So now you use the calculator or a log table, then you will easily get the values of log 3 and log 2, and after dividing you will get our final answer will be 1.5849. This is our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.